17th. So y equals
negative 7x.
-7x. And you're given a table.
Yes.
I don't like the vertical table, but that's what it is. And
X is 0. X is -1. 1 is negative. No, just 1 on X. 1 on the left side here. No. -1. That's fine.
are we given y?
No.
No.
That's final one.
Okay, so 0 times -7 is 0. 1 times -7 is -7. -1 times -7 is 7. So now when I plot, I will plot 0, 0. 1 comma -7. 1 comma -7. 4, 5, 6, 7. 1 comma -7. Y equals -7x.
So that's all we have to do on this. Why do we have to choose -7?
Because this is the ordered pair. 1 comma -7 and 0 comma 0.
Right.
Good. Anything else? Other questions for me? Anything else? Let's go back quickly to what we did last time and then continue. Okay, so we looked at some questions that you had. Then we looked at graphing and plotting points. We identified the equation of the x-axis as being y equals 0 and the x-axis as being x equals 0. And we graphed, we said there are 4 different lines when it comes to their slope: positive or increasing, negative or decreasing, 0 slope, and undefined slope. And then we graphed several equations, and then we said that there were 2 methods of graphing linear equations, using the x and y-intercept, the second one, which I prefer always, and graphing using the slope and the y-intercept. I'm sorry, I'm missing a T here. I know how to spell intercept. I don't know why. Maybe it got cut off. I don't know. Sorry. We found the x and y-intercepts, and we plotted and we graphed, and then we looked at 2 different equations for the line y equals mx plus b, where m was the slope. And then we looked eventually at the second equation, which was point slope form. Y minus y1 equals the slope times x minus x1. And what else? Parallel lines and perpendicular lines. And then we were asked whether the given equations were represented equations or lines that were parallel or perpendicular. So we determined, since the 2 slopes were both the same, they were 6/5, we concluded the lines were parallel. Perpendicular lines, there was another situation in which we determined the slope of the first one to be 3/5, the slope of the second one to be -5/3, and the lines turned out to be perpendicular. Why? Because the product of the 2 slopes is -1. And then we looked at a word problem, and then we looked at another word problem, and then we stopped. So one more time, here's where we are. We just finished last time equations of lines, so we're going to look at functions and solving systems of linear equations by graphing. I'm going to do this first and then come back to functions. Bless you. Any questions for me? As I mentioned, I posted all your grades, everything you had. I adjusted your test grades based on the points that I consider that you fully deserved looking at your work. And I want to thank you for presenting your work, detailed work, so I can look at it and see how much extra credit I can add to your grade. That is the best. And make sure that you label everything so I can identify it easily, so I don't have to look on 3 different pages for problem 5. Okay? So that was very good. I appreciate that. Okay. I would like to look at section 4.1 and then come back to 3.6. And the second, let me look and see for a second. When did we schedule our second test? I think is it next week or the following week? Okay, it's the following week. You have Monday the 26th through March the 2nd. Homework is due next Friday. So today we're going to finish, but I'm going to start reviewing for this test. Okay? And also on the 24th, we're going to review for test 2. So please make sure everything is done for test 2 as soon as possible. So the sooner you do everything, the more questions you may have on the 24th, and we can finalize and wrap up test 2. Okay? Interim grades are due here, which means I will still have to make an assessment of your performance so far based on what you have. Okay? Homework and test. Because test 2 runs including March the 2nd, so please arrive to the testing center, not to the computer lab, at least 2 hours before they close. Okay? For test 2. Okay? Good. So let's go back. Let me see where I'm at. Yes. Okay. So let's take a look at 4.1. Chapter 4. Chapter 4 deals with my other class. My other classes in here asked me to do this. Is this better for you?
Yeah.
This one, both.
Yeah, just like that.
Is this better?
Yeah.
Okay, awesome. Sorry, I didn't know. My apologies. Okay, chapter 4. Chapter 4 deals with, the whole title is Solving Systems of Linear Equations. What is a system? Solving systems of linear equations. And I want to give it a heads up. Chapter 4 deals with 3 methods. One method will be part of test 2. The other 2 methods will be part of test 3. So 3 methods. I still have not defined what a system of linear equations is. I will in a minute. So 3 methods. The first method that I'm saying is part of test 2 is solving by graphing. Three methods of solving systems of linear equations. The first one is by graphing. Second one is by substitution. And the last one by elimination. Do not worry about the second and the third just yet. And now I'm ready to define what a system of linear equations is. And I am going to read a question. I am on page, you don't need the book, I'm going to read the problem to you. I'm looking at problem 12 on page 292. Yes, it's in 4.5. Don't worry about it right now. You'll see in a minute what I'm trying to do. The sum of two numbers is 76. I would like you to come up with an equation that fits the information we have. The sum of two numbers is 76. Awesome. I'm reading on. Their difference is 52. I'd like someone to give us an idea of how to write this.
X minus y.
X minus y equals 52. This is a system. System of two linear equations in two variables. This is what we call a system. What does it mean? Two conditions put together. I'm trying to find how many variables here? Two. How many equations I need?
Two.
And what am I trying to do? I'm trying to find two numbers that verify both equations at the same time. This is a system of two linear equations in two variables.
So it's just multiple formulas?
Yes, multiple equations. Multiple equations or conditions that have to be fulfilled at the same time. Yes, about the same variables. See, if I have two equations, the first equation has a and b and the other equation has x and y, I can solve, right? Because they have nothing in common, right? So here we have two equations in the same two variables. They have to be fulfilled at the same time. Okay. Now, before we illustrate how to solve the system of two linear equations, two conditions to be fulfilled at the same time by graphing, I'm going to ask you, what is this? X plus y equals 76. What does it represent?
The x-axis.
It is a line. That's right. It's the equation of a line. Correct? Okay. What does x minus y equals 52 represent?
Same thing.
Another equation of a line. Good. So now let's think for a moment. In how many ways can two lines face one another? Imagine two roads. Okay, so they can be indeed parallel. How many, if the first line and the second line, if they are parallel, how many solutions will I be able to find for this system?
Infinity? Nine.
Exactly. They will never meet, right? The slopes are the same. We know that. And those two lines that are parallel will never cross, right? There are streets that we know of. They never cross, right? They're parallel.
Right.
Perfect. So that's one option. Second option. Not perpendicular, just they intersect. They can be perpendicular or not, but they intersect. In how many points can two straight lines intersect?
One.
What about two?
No.
No. It's one, none, and here's the third option. In how many points do these two lines meet?
Infinity.
All. Infinity. Exactly. So these are the only three options. So every time you give me a system of two linear equations in two variables, I know the answer. It can be this, one solution. It can be this, none, or it can be this, all. At least I know, I should have the correct statement is I know what to expect. Okay? And then I know it has to be one of the three. So let me write this down. 3 possibilities. Here they are. It's cold here too. Are you running from cold or?
No, the outlet.
Oh, okay. This is one line. And this is the other line. We have some ready? So here we have to remember a few things. This situation is what we call unique. Just one, unique, one solution. The system is called consistent. Terminology is very important here. Consistent system. The equations are called independent. Important terminology. Number 1. How many solutions? Unique. Just one. Single solution if you want. If you don't like the word unique, just say one solution. I'm fine. How is the system called? The system is called consistent because it has a solution or many. It's called consistent. How are the equations called? Independent. How many solutions does the second option have?
None.
No solutions. Parallel. No solutions. Parallel lines. Will the system be consistent? No, inconsistent. Inconsistent system. And we do not have a name for equations here. How many solutions in the third option? So this is option 1, option 2, option 3. Third option, how many solutions? Infinitely many solutions. Dependent equations. Consistent or inconsistent system?
Consistent.
Of course, it has solutions. One or many, doesn't matter. Consistent system. Very good. So we have our system. This is our system. We're trying to solve it. Ready? I'm gonna copy it one more time. X plus y equals 76. X minus y equals 52. You gave me the equations. Do we understand how we got the equations? Is this clear? Right? Should I read the problem one more time? Or is that understood? Is that a yes?
Yes.
Okay, very good. Once I posted solutions, I adjusted most of the grades because I saw the work. As long as you were very organized, most of you were very organized on paper. It was very easy for me to, I didn't have to look for, you made it very easy for me to find the problems. You don't have to perform them in order. It's nice for me. It's easier for me too. But everything was labeled, and it was very easy to read. Thank you for that. Okay, very good. So I'm going to try to graph the first equation. X plus y equals 76. Which two ordered pairs are the best for graphing? That's exactly not the best. It's good, but not the best.
0, 1.
Careful. go back. Here are your solutions, test 1 solutions. I posted them, Alyssa. Solutions are up here. In this module, I posted solutions to the test.
Okay.
I printed it out and I posted solutions. Okay, so one more time, last time, please. Graphing linear equations. Graph using the slope and y-intercept, not recommended. Graph using x and y intercepts, highly recommended. And that's what we did. So please remember, highly recommended. Why? Let me explain again. Only the linear equation can be graphed using the slope and the y-intercept. And this is it. No other function can be graphed using slope and y-intercept, ever. Move away from the method. It's not good. It's allowed, it's safe if you want, it's okay. Waste of time. Okay, good. How do I determine the x-intercept? What do I have to do?
Subtract y.
Careful, we don't solve for anything. I'm trying to find the x-intercept. What is the equation of the x-axis? Y is 0. So please make y equals 0 and give me x.
76.
Very good. What is the ordered pair that we just determined?
76.
Very good. I'm trying to find the y-intercept. What is the equation of the y-axis? Its position.
Right, x is 0.
Thank you. I covered it. It's gone. How much is y?
76.
Please give me the ordered pairs. I'm sorry, the ordered pair, the point.
0, 7.
Perfect. So let's graph. I am going to try to be as accurate as possible. It doesn't mean that my graph will be remotely accurate. I'm going to try. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say 76 right here for this. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say, obviously, it's not perfect. This unit is not the same with that. It can be perfect. Okay? So this is the line. I connect and extend. I graphed x plus y equals 76, 76, and 76. Okay, I'm looking at the other equation now, and I have x minus y equals 52. I need to find the x-intercept. What do I do to find the x-intercept? I know I look silly, but maybe I can look silly, but if you remember this, I'm fine.
Y equals 0.
Thank you. Because that's the altitude, altitude 0, right? So I make y equal to 0. I covered it. It's gone. How much is x? Very good. What is the ordered pair then?
52.
Very good. Now I want to determine the x-intercept, the y-intercept. Position.
The x equals 0.
X is 0. It's gone. I covered it. How much is y?
Negative 52.
Thank you. What is the ordered pair?
0, negative 52.
0, negative 52. I'm going to try. I'll do my best. See what I come up with. Ready? 52 comma 0. So 1, 2, 3, 4, 5. Somewhere here. 1, 2, 3, 4, 5. Somewhere here. Connect and extend. I graphed x minus y equals 52. Now I stop for a moment and look at this graph. I know that when I solve systems in two linear equations, with two linear equations in two variables, there are three possibilities. 1, possibility 2, and possibility 3. Which one is this?
1.
1. Unique solution. One solution. There are only two numbers on the planet whose sum is 76 and difference is 52. If I find those numbers, you cannot find another pair. If I'm correct with my ordered pair, you cannot find another one that works. Is that clear? Yes? Okay, perfect. Here's the difficulty with graphing, especially without having a graphing paper and with, the units that are not 100% and they are not exact and my graph is far from being accurate. I have difficulties reading. So this is the point. This is the only point that verifies both equations, but I have no idea what it is. I really don't. Can I read from this graph? No. Here is the method that I recommend to my students in this particular case. And if you give me this problem and you say solve on a test, quiz, whatever, and you say solve this, and you have to solve it by graphing. On scratch paper, I can do whatever I want. I do my algebra on scratch paper. And here's the algebra I do in this particular situation. One of these two. How do I do it? So I write the system one more time. And let's say I solve the first equation for a variable. Which one do you want?
Substitution.
Exactly. Solve for one of the two variables, whichever you want. Which one?
X.
Okay, so then x will be, I move y, negative y plus 76. And then what do I do with this? Replace x in the second equation by what x equals to. I know that x or negative y plus 76 is the same thing. So then I'm going to replace this by negative y plus 76. So negative y plus 76 minus y equals 52. Combine like terms. Negative 2y. Move 76 to the other side. What do I get when I move 76 to the other side?
Minus 76.
Of course. So negative 76 and 52. I have 24 with minus.
Y equals 12.
Y equals 12. Is this good enough? No. If I have y, now I go back here and I can find x. Now I replace y by 12 with minus in front. 76 minus 12 is 64. So what is the solution? Can anyone give us the solution?
64, 12.
Yes. I don't trust it. Not yet. I do this now. 64, 12, 64, 12, and make sure that the ordered pair 64, 12 works in both equations. I don't know. 64 plus 12, is that 76?
Yep.
64 minus 12, is that 52?
Yep.
And then I come back here and I'll say, look, I can read. So my graph is so accurate. Look, I can read now 64, 12. If you don't believe it, you find it. Of course I didn't read it from my graph. I couldn't. My graph is far from being perfect. But I had the solution, obtaining it by substitution. I did it algebraically, and I didn't have to worry about my graph. Now, if you do this on the computer, it's a different story. Or calculator, and let's do it. The problem with the calculator, however, is that I have to solve for y, both equations. because I can't plug in y equals anything but y equals. So in y equals, I have to solve the first equation for y, which will be negative x plus 76. Negative x plus 76. I go to the second one, I have to solve for y. It's x minus 52. I'll show you how I solved in a minute. I should have showed you that before. And now I will graph using standard viewing window. Let me, no, I think it's fine. I don't need that yet. So standard 6, press on zoom, standard 6. Wonderful, I don't see anything. Why I don't see anything? I don't see anything because this is negative 10, 10, negative 10, 10, and the graphs are up here, or up here. So I have to adjust the viewing window. The standard viewing window is not working. Yes? Yes. You have to clear the plot that you have here. And then second and graph. Or just graph, I'm sorry. No second. No, just graph. Just press on graph again. Yeah, we have to change the viewing window. It's graphing something else. So we have to change the viewing window to standard. So you don't see anything just yet. So since I did my work, since I graphed these lines, I know that the standard viewing window is not going to work. Right? The intersection is at 64, 12. Of course I don't see anything. So let's adjust the viewing window. I don't really need to see the negative side. Everything happens on the positive side. So x minimum can be 0. I'm fine with that. But x maximum has to be, if I want to see 64, I'm going to put 80 with a scale of 10. Y minimum, I don't really care for a lot of minimum or negative part, but let's say negative 5 or negative 6. And Y maximum, I wanted it to be at least 12, right? So I'm going to say 80 because I want to see both x and y intercepts. So with a scale of 10. And now I can click on graph again. Ah, here they are. So that's the first one with a negative slope, and that's the second one with a positive slope. And as expected, I see the solution. I cannot read it again, but the calculator has an option that is very nice called intersect. I'll do this again if you fell behind, so or tell me to stop. So second and calc. Which of these items will I pick for what I'm trying to do? Bless you. Which one? Of course. I'm trying to find the intercept. So let's pick 5. It's asking me if that's the first curve. I will say yes. It jumps to the other one. Yes, I'm going to say yes. No, I refuse to guess. Please come in. I refuse to guess, and here it is. And the intersection is 64, 12 as expected. No, you have 2 points here. So miles is on the x-axis and money up here. So you have 480, 380, 480, 380, and 860. Those are the 2 order there. So coming back, I need to show you 2 things. Remember, I cannot put in the graphing calculator this. So I had x plus y equals 76, and I had to solve for y. Y equals negative x plus 76. This was the first equation we plugged in. Then I have to solve the second equation, x minus y equals 52. I have to solve this one for y, and here's what I did. X minus 52, because this was negative, I moved it to the other side. So these were the 2 equations I put in the graphing calculator. Were you able to follow the steps, or should I do it again? So in y equals. We already have those two equations, right? Then you go to second and calc, and you choose intersect, which is number 5. I don't know if I click on that, it's going to do anything. No, I have to pick 5. And then it will ask you which one is the first curve, and you say yes. Second curve, the red one, yes. I don't want to guess, just give me the answer, and it will give you the intersect, x comma y. Any questions? So you can say, but if I can really tell the solution from graphing it, why even bother with the method of solving by graphing? Because it's useful. It's useful. We're going to look at other functions later on, less in this class than in the next, to find intercepts. And it's a legitimate method. I was not able to read it from my graph. And knowing algebra is very powerful. I did my work. I said, oh, look, so easy. No, it's not. Any questions? Okay, let's solve one more, because we are doing basically two methods in one. So let's find another problem. Find write an equation and solve it. Okay, here it is. Problem 8 on page 292. And then we go back to the last section, 3.6, and then start reviewing. The total of two numbers is 16. The total of two numbers is 16. Yes? Anyone? Perfect. Thank you. The first number plus 2 more than 3 times the second equals 18. The first number plus 2 more than 3 times the second equals 18. What is the first number?
X.
Plus
2.
2 more than 3 times the second.
3 to the second power.
3 times the second.
3 times the second power.
Yes. Equals 18. Let's read it one more time, just to make sure. The total of two numbers is 16. The first number plus 2 more than 3 times the second number equals 18. Is that correct? Is that okay?
Yep.
Perfect. I claimed that the first equation is cleaned up. Remember? Simplify factor is always in the back of our minds. I claim that the first equation is cleaned up, but I claim that the second equation is not. It's not fully simplified. I copy the first one, and please dictate the second one. I don't know how Corey can sit here
I'm good.
with only one little. Anyway, yes. Yes?
Yes.
How do I clean up the second one? Please.
Move 2 to the other side.
Exactly. So I have x plus 3y equals? Good. Perfect. In order to avoid what I encountered a few minutes ago, I am going to solve it by substitution now. So, which one we substitute for? Which one we want to solve for?
Top on the solver.
For which one? For which of the two? For x. Perfect. So again, it's negative y plus 16. What do I do with this? Replace x in the second equation, and the second equation becomes?
Negative y plus 16 plus 3y.
Next step, I must do what? I must combine like terms. Awesome. So then I have 2y plus 16 equals 16. Subtract 16 from both sides. I get 2y equals, perfect. Therefore, y equals, very good. That's not enough. I have to go back and solve for x. How much is x?
16.
Perfect. What is the ordered pair that I don't trust just yet?
16 and 0.
Very good. Has a question mark. I don't know. I can make so many different mistakes here. It's not even funny. So 16, 0, 16, 0. 16 plus 0, is that 16? 16 plus 0, is that 16? Good. Now I claim that these two lines definitely meet in only one point, and that point is
16 and 0.
Yep. That should not be that difficult to figure out, right? Because it will be on the y-axis. I'm sorry, on the x-axis. Very good. So let's graph. I have x plus y equals 16. I'm graphing because I'm asked to graph, not because I want to graph. So when x is 0, how much is y? And the ordered pair?
0 and 16.
Very good. When y is 0?
X is 16.
So 16, 0. I can plot those and graph the line. And I have 16, 0. I'm going to say 5, 10, 15, 16. 5, 10, 15, 16. Here's the equation, the graph of x plus y equals 16. And now I have to find x plus 3y equals 16. Okay, when x is 0, y is good. It's going to be a little hard to plot that, but that's okay. So 0, 16 thirds. And when y is 0, so 16, 0. No problem. 16 divided by 3 is 5 and a little bit, right? 5 and a little bit right here. It's further closer to the, but that's fine because this was 5, 10, 15. And this is the equation x plus 3y equals 16. Can anyone give us a solution?
0 and 16.
And no one said anything. Sorry. Sorry. It's no one's fault but mine. I reversed the ordered pairs. I have to erase the red line. Sorry, sorry, sorry. Can anyone give us a solution? No, I wasn't trying to trick you into anything. I just reversed the ordered pairs.
It's okay.
Sorry.
16, 0.
Yes, thank you. See, that's why I do it algebraically first. You never know. Sorry about that. So, indeed, as expected, 16, 0. It hit me when you said, rightfully so, 0, 16. No, no, no. It's 16, 0. And I said, uh-oh. I see what I did. Indeed, the green line, the blue line, they meet at 16 commas. Thank you. This is the method of Solving systems of linear equations in two variables, two equations, two variables by graphing. And you can say you didn't really graph. You solved it by substitution and then you graphed it. Yes, I did. That's true. In this case, it wasn't difficult to read from the graph. I really didn't have to do my work, but I prefer doing the algebraic so that I don't have to mess up the graph, which I already did. Very good. So last section here is 3.6. Functions. Everything in math is about functions. Just everything. Let me cut the video